we're just continuing from yesterday, and we're starting by getting these prepped. So if you haven't already, take a few moments and get these graphs prepared for yourself. I've had people ask how I can cut them out so quick, and this is kind of how it works.
That was me.
Yeah, it was you. But so you can see it in action, this is what it looks like. This is much harder doing it where it's like away from me and not in my normal comfort cutting zone.
So we're using those big graphs today.
Yes, sir. We'll be using all 4 big graphs today, and when you're done with today, you should have an extra notebook check grade.
What?
An extra notebook check grade.
When are you going to check them?
Today or first thing tomorrow morning. Depends on when you get it finished. Yes, it will take 2 full pages. Yesterday I also took 2 full pages, not because there's a lot to write, but because these graphs are big. All right, put them in this order. Rectangle. Triangle. Trapezoid. Right triangle. This is the order that we'll be working with them today. Woohoo! Woohoo! Yeah, rectangle, regular triangle, trapezoid, right triangle.
This is just a continuation, right?
Yeah, it's just a continuation. So you don't need a new title, you don't need a new objective, you just go right into it.
Continuing from yesterday, right?
Yes, sir. All right, so let's look at what we did yesterday. Yesterday we started the discussion on rotations. We looked at different angle classifications. We had a bunch of new vocabulary because we were talking about the different things that go on to making a rotation, and then we constructed a rotation. Today we're going to deal with the algebra of rotations. And these are actually hopefully going to be a lot easier to handle. So go ahead and set up 2 full pages for notes. Oh, my voice cracked. Along with your left side margins.
Can I start when I should pencil?
I do. Pencil or pen? You're welcome. All right, here we go. That's what the world looks like when I first wake up in the morning. Like that. And then I find my glasses and suddenly it looks like that. All right, so the first rotation that I want to talk about today is the 90-degree counterclockwise rotation. And what this rotation asks you to do is to take your coordinates x, y, and change them into this. What did we do?
You change the y to negative and then switch to x and y, right?
Yeah, we made the y a negative value and then we exchanged the positions of x and y. So we're going to be doing that to the first graph. Practice. That's what I did. Start a pen pal. All right, so the first thing we're going to do is I'm going to list out the current coordinates that I have. A, B, that's a B, C, and D. And thankfully, the picture gives me the coordinates. So I really don't have to think very hard. All right. And now I've got to figure out the new coordinates of the rotated points. You said that all it asks you to do is exchange them and make the old y negative. So a prime will be
Negative 4, 2.
-4, comma 2. From a new voice, what is the coordinate for b prime?
-2, 4.
-2, 4. Thank you, new voice. From another new voice, what is c prime?
6, 8.
6, 8.
Oh, wait.
It's -6, 8.
-6,
I was
8.
right.
Yep, you were right. And then another new voice, d prime.
Negative 8, 6.
Perfect. Graph it. All right, make sure I'm graphing them right because I messed up a couple periods ago. Oh, and always label your points as you go so you know which one is which. Okay, did I get them in the right place? Looks like I did. Did I get them in the right spot? Yeah?
Yeah.
All right. Take your straight edges and make sure that you fill in the lines between the segments. Again, making sure that you connect them in the same order they're connected in the pre-image. There you go. That's it. That's rotation, 90 degrees, counterclockwise. Questions? Really easy, right?
Yes.
All right. Curtis, I see you squinting, sweetheart. Here's the notes from previous class break.
I'm fine with it. I just
sure?
have it.
Okay. All right.
Yeah.
I can see without
Every time I squint, for the doctor.
Okay. I worried for you, sweetie. All right, we're going to do 180 counterclockwise rotation. And what 180 counterclockwise rotation asks you to do the coordinates is this. What'd it do?
Make them both negative.
Yeah, that's all it did. So you're going to grab the next graph, which should be the triangle ABC. And we're going to do 180 counterclockwise rotation on that graph. All right, just like the other one, we're going to start by listing out our coordinates. And just like the previous graph, this one has the coordinates listed for me, so that part should be fairly painless. All right, from a new voice, can I have a prime?
-4, -2.
-4, -2?
Oh,
Negative 5.
Yeah, +2. Because it already has a negative, you see? Yes, you're just changing the signs. So what was B prime? You were already starting to say?
Negative 5, negative.
B prime would be -5, -5. C prime?
Negative 1, negative 3.
-1, -3?
1, negative. Oh, yeah.
Yeah.
One's already negative.
Yeah, the one's already negative. So just change the sign. All right, graph it. Did I get the points in the right spot? Did I do good? Yeah?
I haven't even started it yet.
Yeah, okay. I'll wait. I've got a 1 yes.
Yeah.
Yeah, that's 2. All right, don't forget to take your straight edge and connect the points. Do you mind having the side conversation later, please? Thank you.
No, my sister, you're going too fast.
Oh, okay.
No, so
Right.
if it's already negative.
It turns into a positive, yeah. You're just changing the sign. So where are you at? Oh, you were at the bathroom kind of at the beginning, yeah? Yeah, okay. I have an extra notebook if you want.
For C prime, was it a negative 3 for K?
It is supposed to be a -3. Thank you. Questions on this one? All right, before we move on, one of my classes, I don't remember if it was this one or another one, had asked me when we were doing reflections, hey, couldn't I get a reflection from just rotating it 180 degrees? And my answer at the time was, I'm not really sure. Let's wait till we do rotations and check. So now that we've done the 180 degree rotation, if I put my popsicle stick here between them, kind of equidistant between them, does it look like a reflection?
No,
Why not?
because it's shifted slightly. If they're a reflection, it should be completely even.
Yeah, it should be completely like on the exact same spots, but just on the other side of the line. I should be able to fold it on the popsicle stick that I've got here and have those two triangles match up perfectly. But since I can't, they won't match up properly if I try to fold it. It's not a true reflection. Something else happened. In this case, it's a rotation. All right, nicely done. On to the next one. I'm out of room on this sheet of paper. You probably are too. So go ahead and follow me over to the next page. It's going to be the trapezoid. We're going to do a 270 degree counterclockwise rotation. And what this asks you to do to the coordinates is this. What did it do?
It flipped them and made the X negative.
It flipped them and made the original x coordinate a negative value. All right. Let's do it. I need letters for the vertices, don't I?
E.
E.
Lots of vowels today. Now notice when I'm writing these letters, I'm starting at any vertex I want, but then I'm going in order and I'm following the sides. So since I started on A, I have to go to C or E first. I can't go to U. Okay? So when you're naming these figures, start at a vertex, any one you want, and then just walk around the outside edge of your shape to name it. All right, this one I wasn't given the coordinates, so I'm going to have to count. So I'm going to zoom in to try to make it a little easier to see what I'm doing here. Each one of these little squares is worth 1. 1, 2, 3, 4, 5. So A is on 4, 2. C is on 2. 1, 2, 3, 4, 5. 6. U is on 3, 6, 7, 8. And E is on 5, 6, 8. Questions on how I did that? All right. Looking at your algebra notation that's off to the left-hand side of the screen and not currently visible. The algebra notation? So let's show that algebra notation again real quick. The algebra notation says, take the x and y coordinates, make the x negative or change its sign, and then flip them.
Okay, 2, -4.
So the first one's going to be 2, -4, she said. New voice for coordinate of C prime.
6 negative 2.
6, -2. Coordinate of U prime.
8, -5.
8, -3. And the coordinate for E prime?
E -6.
All right. Bless you. Graph it.
Okay.
You're very welcome.
Oh, thank you.
And again, as always, make sure that you label the points as you've rotated them, just so you can keep track of which ones you've done. It's going to be especially important if I decide to be wonderfully cruel and give you like 20 or 30 different points. I won't. That's way too many. But if I give you a whole bunch of points to rotate, you got to be able to keep track of them. Okay, so label them as you go. Once you are certain you've got them in the right spot, bust out that straight edge. If you don't have a protractor, you can use a popsicle stick, the edge of your cell phone, the edge of a calculator, a piece of paper, your notebook, anything that is straight and has an edge that you can trace with your pen or pencil will work. Pretty cool, huh? Not bad, right? All right. Now, for each one of these rotations, the only thing that you weren't told was its center, right? I didn't tell you where the center of rotation was, did I? Yeah, I didn't. You noticed. You're wondering.
No.
Oh, you had it on that. Yeah. So the center of rotation is going to be at the origin on all of these. So all of these transformations, all of this algebra stuff happens when the center of rotation is at the origin. Okay. So what we're going to do is we're going to write that center of rotation at the origin for each one of these items. So take a moment and go back and add that the center of rotation is at the origin, which basically means that its coordinates are 0, 0. I'm writing that for all of them. And I'm going to take my pink highlighter and just put a bright pink dot on the origin, just so I can visually see it. All right, so now I have my direction of rotation. I know we're going clockwise or counterclockwise. I have my center of rotation, so I know which dot I'm spinning it around. And I have my angle of rotation, so I know how far I go before I stop. I want to look at them one more time. So we're going to start here with the 90 degree real quick. If I told you that this line right here, the x-axis, I wanted you to consider that as 0 degrees, where would 90 degrees end up? The x-axis is 0 degrees. Where's the 90? On the y, up here somewhere. Which means that I'm rotating from the 0, the x-axis, counterclockwise 90 degrees. I'm going that way that far. This concept remains the same in trigonometry, algebra 2, and calculus. So hang on to this piece. Okay? So the question is, what if I started in the same spot? But instead of going counterclockwise, what if I went clockwise? How far in degree would I need to go to end up in the same location? 360? 180? Yeah, these are all wonderful guesses. All right, let's look at this real quick. I'm going to put I guess this one here. Okay, so I started here. And counterclockwise, I went this way and I got to 90. And I want to get back to this orientation with my paper clip kind of facing straight up and down. But I want to go the other way. So if I spin this way, how far have I gone? I've gone 90.
Oh, yeah.
Okay? And then I'm going to keep spinning, and now how far have I gone?
90.
I've got another 90, so a total of 180. And I'm going to go this far, so how much further? Another 90. So 180 plus 90 is 270. So I've gone 270 degrees clockwise to get to the same spot as if I had gone 90 degrees counterclockwise. Those two rotations are completely identical. They do the exact same things.
Oh, you found it.
All right? Let's look at the 180 rotation. So 180 counterclockwise is going to start here at the 0. We said this was 90. So this over here was 180. So 180 counterclockwise is this. Start the same spot but go clockwise. How far do you have to go to get to the same spot? How far did I go to get from here to the same place? 180 also. Do you notice a pattern with these numbers?
They all equal 260,
They all equal 360,
which is a full rotation.
which is a full one rotation around the circle. So if anyone ever tells you, I don't like your attitude, you need to do a 360.
We're going back to the same.
I want you to just laugh in their face and go, okay, I'm not going to change. They want you to do a 180. That's what they're looking for. They want you in a different spot. Yeah, my mom said that to me once. Oh, she slapped my face so fast. Yeah, it wasn't fun. All right, so we're going to go counterclockwise now. We again said this was 0. This up here was 90. Out here you said was 180, and so this one down here must be the 270. So if I go counterclockwise 270, I end up here. How far is that clockwise?
Wait, what did you say?
We started here and we went 270 degrees counterclockwise. And the question is, if I start at the same spot, how far do I go clockwise to end up in the same place? 90.
How? Please, how?
We don't ask such questions of him. 90 degrees clockwise. Make sense? Now you can do 6 different rotations. Pretty cool?
Oh, 'cause they're-
Yeah. Because we have 3 main rotations and 3 rules, but each rule can handle 2 different rotations. All right, let's glue the last one in and I'll tell you what we're doing with it. Make sure that you have the X and Y facing in the right directions, because I messed that up already once today too. I am all sorts of messing up today.
It's okay, everyone is.
Thank you. For a notebook check, what you need to do is the following.
Rotate. Oh.
Yeah, draw the rotation, or rotate, yeah. Draw the rotation of triangle, whatever you want to name it.
Wait, this is a notebook check?
This is going to be a notebook check. Whatever you want to name the triangle, and I really don't care.
Oh, so you like only the points like 8.
Yep, you label the vertices. I don't care what you name it. You can name it whatever you want. You can be as inappropriate with this name as you want. This is your notebook.
Are you grading?
I'm going to grade it. I'm not going to say anything about the appropriateness of whatever you decide to name it. I'm just saying. But be wary if someone else decides to look at it, they may go.
I put pop.
I put cub.
You can't repeat letters.
Ah,
Because if you repeat letters, you're saying they're the same point.
I put Noe, like it's the Noe. The mascot.
Okay, so draw the rotation of triangle blah about the origin. So you know your center of rotation is going to be right there. And then I need you to tell me what direction you are going to rotate.
Any direction.
Any direction. There's no wrong answer, well, except for maybe up. You have to choose clockwise or counterclockwise. You can't rotate up.
Be quiet.
And then you need to tell me how far you are rotating. So you need to give me your angle of rotation.
Could we repeat the rotation of one of the three that we did right now?
Yes. The only, what's the word I'm looking for? The only restrictions that I'm going to place on you, on your angles of rotations, is they may not be 0 or any multiple of 360. Because those don't do anything.
Is 90?
90 is not a multiple of 360. It is a factor of 360,
Oh, okay.
but it is not a multiple. So any number that you can multiply to 360, whatever you get out, you can't use. So 360 times 1, 360 times a million, don't use those.
We're doing the exact same thing?
Exact same thing. Now, here's how I'm going to grade it, and this will decide for you exactly which one you're going to want to do. All right, for the grade, if you give me only the algebra, which is exactly what we did today, I will give you a 95 and smile and move on.
Yay.
Yeah. If you want the 100, you must make it a construction, which is the technique we did yesterday
Which is
with the compass and protractor.
I don't remember that.
Which means that if you're struggling on the construction, this is a good time for you to get that little bit of extra practice. You can run the algebra. You know for sure you're going to get the 95. And then you can run the construction on top of it. And since you've done the algebra, you should end up on the exact same figure that the algebra told you it should be.
Well, Miss, how did you get T?
What
For
T?
for yesterday's? How
Yes?
The T? How
So
did
she
that
just
make
labeled it.
But like, you drew something.
So she did a
Okay, let me end the video, and then you and I can sit together and we'll do the construction together, okay? Okay. All right, any questions on the notebook check? I will take it today or tomorrow. You said you were going to be out tomorrow? Maybe. Okay, so I want to see yours today and make sure that I write it down in my grade book today, so that way you have it and it's done. Everyone else, I'll grade it, but I'll put it in my grade book tomorrow, so just show it to me tomorrow, okay? All right, thank you very much.